doing probability exercise 15.1 and question 1 for that. So question 1, it says complete the following sentences. First part. So first part is probability of an event E plus probability of the event not E is equal to dash. So we have done in our concepts part also, probability of an event plus probability of not E is equal to 1. Correct? So that's fine, I think. Then second part, the probability of an event that cannot happen. So cannot happen is definitely it will have probabilities as 0, and this kind of event is called as impossible event, right? Because it cannot happen. Like I can give the example, like what is the probability of human beings having a tail, right? So it's an impossible event kind of thing, so that's fine. Now probability, third part is the probability of an event that is certain to happen is dash. Such an event is called dash. So we know sure to happen means probability is going to be 1 definitely, and it is called as sure event or certain event. Correct? So we can say like that. So it is definitely like we say, okay, it's very very cloudy and it has become dark, so we say probability of going to rain will be 1. Like it's sure, it's going to happen definitely. So that is fine. Now fourth question, fourth part of it is the sum of probabilities of an elementary events of an experiment is dash. So I think we have done these type of questions a lot of time, and we have done in our concepts also, but let me explain here. Suppose if I have a bag in which I have 1, 2, 3, 4, 5, 6 balls. Let it be 6 balls. So these 6 balls, let me have 3 balls blue balls, and let me have 2 green balls, right? And okay, let's have 1 red ball. So that's fine. Now so I can say that my total number of balls are 6. Okay, and red balls are how much? 3. Then I can say green balls are 2, and red ball also I have 1. Okay, so now in our 9th grade we have already done this formula that probability of an event is equal to number of favorable outcomes, right? Favorable outcomes by total number of outcomes. This we have done this thing in our thing. So in this experiment, this is called an experiment, like taking out a ball from a bag will be an experiment, and my elementary event will be probability of getting a blue ball, right? So getting a blue ball will be equal to 3 by 6, and probability of getting a green ball will be equal to 2 by 6, and probability of getting a red ball will be equal to 1 by 6. So these are my 3 elementary events of the experiment. Experiment is taking out the ball, right? So these are the 3 elementary events. So sum of elementary events means probability of blue ball plus probability of green ball plus probability of red ball. So probability of, let's add these. So this 3 by 6 plus 2 by 6 plus 1 by 6. So now my LCM is 6. 3 plus 2 plus 1, so 6 by 6. So this I am getting as 1. So always you can remember this, you have understood by the concept. So my answer will be 1. So sum of probabilities of elementary events in an experiment will be equal to 1. Okay, now let me move to Fifth part now. So fifth part says the probability of an event is greater than or equal to dash and less than or equal to dash. So we have done in our concepts parts also that probability is always greater than equal to 0 and less than equal to 1. So my probability will lie between 0 and 1 always, right? So that we have already done. So I think the answers will be 0 and 1. So this finishes our question 1. Let's go to question number 2. So question number 2 says, which of the following experiments have equally likely outcomes? Explain. Equally likely outcomes means in an experiment, suppose the probability of each elementary event is equal, then we say equally likely outcomes, right? So now first part says a driver attempts to start a car. A car starts or does not start. So car starts or does not start means if my car is in good condition, if the car is in good condition, okay, so it will start. And but suppose if the car is not in good condition, or my battery is down, right, then it will not start. So this does not depend on starting or not starting. It depends on the condition of the car. So I can say that this experiment does not have equally likely outcomes. Does not have equally likely outcomes, right? Okay, so now second part of this question. So second part says a player attempts to shoot a basketball. She or he shoots or misses the shot. Okay, so now in this question, suppose if someone is good player, right, he or she will shoot, right, and if someone like me okay, is not a good player, then it will miss. He or she will miss, right? So it does not depend on shooting the ball. It depends on the player, if he's a good player or not a good player. So for this also I can say there's this experiment does not have equally likely outcomes. Does not have equally likely outcomes, right? Okay, now third part of this question. So third part says a trial is made to answer a true false question. The answer is right or wrong, right? Okay, so the conditions are true or false. So it can be either right or wrong. So equally likely outcomes, right? So yes, this experiment has equally likely outcomes. Yes, because it does not depend on the condition. A statement will not change. A statement will remain the same. A statement is same. It does not change. So it can be either right or wrong or true or false. Okay. So now let me go to fourth part of this question. Fourth part says a baby is born. It is a boy or a girl. So it can be either boy or girl, right? So there is nothing like more chances. So they have, yes, they have also have equally likely chances. Yes, this experiment has equally likely outcomes. Equally likely outcomes, right? Okay, so we are done with the second question.